In this video, we'll go over the homework that follows the lecture 8.4 called Integration by Parts, but it's different from the previous one because this time we still do integration by parts twice, but the second integral, the second integration by parts results in the same integral, which creates a loop. So we are going to practice these scenarios, and let's go ahead and jump right into the homework. But before that, I want to make sure that you watched this lecture, as I will be making references, assuming that you have watched it and are familiar with some of the basics. So now let's go ahead and jump right into the homework. This problem looks somewhat complicated, but as long as you are familiar with this pattern and the process, then you should be fine. So the idea is very simple. We don't have many choices here. We're gonna set u to be the sine of ln of 5x. Then du will be the cosine of ln of 5x times the derivative of ln of 5x, which is the reciprocal of 5x, times the derivative of 5x, which is 5, so these 5's cancel each other. So the final answer is just times 1 over x. Now dv is just dx, and then v is going to be just x. And as a result, here's what we get. We get uv, so we have x sine of ln of 5x, that's uv, minus integral of v du, but you can see how v, the x, cancel this 1 over x, so we end up with the integral of cosine of ln of 5x dx. And this is kind of, seems like we're not going anywhere with it, but let's continue and let's try integration by parts again, but this time u will be the cosine of ln of 5x, so that du is going to be negative sine of ln of 5x times the derivative of ln of 5x, which is 1 over 5x, times the derivative of 5x, which is just 5, and 5 over 5 will cancel each other, and we'll end up with the same expression here. By the way, I forgot dx here and here. So dv is dx, so v is x, and we're gonna now plug everything in. But again, remember, the integration by parts only applies to this integral. So the first part remains the same. So we still have x sine of ln of 5x. That's not going anywhere. Minus, now we're going to plug in this, the results of this integration by parts. So we have now uv, so I'll put parentheses here, uv, so we have x cosine of ln of 5x minus integral of v du, but the minus times minus becomes plus, so we have integral of v du, and this x will cancel this x when we put it together, so the only thing we have left is integral of sine of ln of 5x dx. And this may look as if we running a circle here, because we literally have now the same exact integral as before. But here's a trick. We're going to refer to the original integral as I or j, so let's just use letter j over here. So my original integral is j. So all of this that I found is just j. But this is also my original integral, so this is also j. So what we have here now is j is equal to x sine of ln of 5x minus, now I'm going to distribute this negative, x cosine of ln of 5 x minus j. So all that is equal to j. And now we're just going to solve it for j. We're going to add j to both sides. So now on the left side we have 2j. And I may try to use the power of the whiteboard and technology. So copy. And let's see. And yep, that's amazing. And now I'm going to divide both sides by 2. And that's my final answer. Just let's not forget to add c right over there. And again, I like to refer to these integrals as loop integrals because they are kind of taking advantage of that loop pattern. And yeah, it makes sense to call them that way. So I'm going to take out the x. So here we have sine of ln of 5x. We have to be careful here. Minus cosine of ln of 5x plus c. And just to be safe, I'm going to throw some parentheses in there. But yeah, that's the answer. So now let's see how this pattern works out in some other problems. Here's another one. So problem number 2. So your job is to try to remember these patterns. So when you see one, you know which technique to apply. Here we're going to do by parts. And here, your choice of u, you can make your u to be e to the power 4x and dv to be cosine of 5x, so that your du is 4e to the power 4x dx, and v, it's 1/5 sine of 5x. Or you can choose your, I'm forgetting dx over here. Let's make sure I didn't forget dx there. Nope, looks good. You can also, and again, it will work out the same exact way. You can also set up your integration by parts like this. U to be equal cosine 5x, and then du will be negative 5 sine of 5x, and then dv is e to the 4x dx, so that v is 1/4 e to the power 4x. And as long as you are consistent and you set up your second integration by parts exactly the same way, then you'll get the exactly same answer. So I'm going to stick with my original choice. So I'm going to remove this, but it will work. It would have worked exactly the same way. So the first integration by parts results in the following expression: u times v minus integral of v du and, like I said, just stick to the same pattern. So I'm going to do u as e to the 4x again. Du is 4e to the power of 4x dx. dv is sine of 5x dx, so that v is negative 1/5 cosine of 5x. And it all would have looked much better if I took the 4/5 out, which is what I'm going to do now. Just so now, continuing with the original integral, we have 1/5 e to the 4x sine 5x minus 4/5. But here we have uv, so we have negative 1/5 e to the 4x cosine 5x, that's my uv, minus, so because I already have minus near v, so it's going to be plus. I'm going to take out 4/5, and I have integral of e to the 4x times cosine 5x dx. And this is where we notice the pattern. We ended up literally with the original problem. So if I let the original integral to be j, then what I really have here is j equals to 1/5 e to the 4x sine of 5x, now I'm going to start distributing, plus 4/25 e to the 4x cosine of 5x. Now I'm going to distribute it over here. So we have 16/25 negative. And this is the original integral. So that's my j again. What do we do from here? We add 16/25 j's to both sides. So here we have j plus 16/25 j. And I'm going to use the power of technology here. And instead of rewriting it, I'll just copy it. On the left side, we now have 41/25j. The right side is the same. And now we isolate j by multiplying both sides by 25/41. And other than that, it's still the same. And don't forget to put plus c. That's the answer. So let's type it up. And you can take out, you can like simplify it a little bit. So we can take out e to the power 4x. And we can distribute 25 over actually. So it's going to be 5 sine of 5x plus 4 cosine of 5x plus c. Very similar problem, so let's just jump right into it. So this was problem number number 2, so this will be number 3. We have integral, this one I'll do the other way. Remember in the previous problem I said you can choose to do your substitution by parts in 2 different ways. So this time I'm going to set u to be equal cosine of 4x, then du is negative 4 sine 4x dx, so that dv is equal to (2x dx), so v is 1/2 e to the power 2x. So now my first result is I have uv, so 1/2 e to the 2x times cosine of 4x minus integral of v du. So we have negative 4, we have 1/2, take it out, so this becomes positive 2. And we have integral of e to the 2x times sine of 4x dx. And we're going to do, again, integration by parts. But u will be now sine of 4x. If now you start switching and you choose your u to be e to the 2x, you're going to literally end up with the same problem as you started with. So you don't want to do that. dv is e to the 2x dx. V is 1 over 2 e to the 2x. So continue. So we have, remember, the integration by parts only applies to this integral. Everything before it remains the same. So I'm going to try to write it as compact as possible. But now the result of this integration by parts goes inside of this parenthesis. So we have uv 1/2 e to the 2x sine of 4x minus integral of v du. So we have 1/2 and 4 comes out, it becomes 2. Integral of e to the 2x times cosine of 4x dx. And this is where we realize, hey, this is exactly the same thing as what we started with. So if I call the original integral j, then this can be rewritten as j equals to 1/2 e to the 2x cosine 4x. Now I'm going to distribute this too. So we have plus e to the 2x sine 4x. Now I'm going to distribute this to this way. So we have -4, but that's the original integral j. So we have -4j. So the next step, we're going to add 4j to both sides. So now we have 5j, and we're going to just copy this over because nothing is being done to that. And next we're going to divide by 5. And let's not forget to add c at the end. So the final answer is we're going to take out e to the 2x. We're going to divide everything by 10. We're going to also take out 1/2. And here we have cosine of 4x plus 2 sine of 4x plus c. This was number 3. And let's do one more. This will be number 4. So we have integral of cosine ln of 6x. We're going to set it up to integrate by parts. U is cosine of ln of 6x, so that du is negative sine of ln of 6x times the derivative of ln of 6x, which is 1 over x dx, and dv is dx, so that v is x. This is my first integration by parts. Let's write the result. We have uv, so we have x cosine of ln of 6x minus integral of v du, but minus times minus becomes plus, and we have x's canceling out here, right? So well, my Control Z doesn't work, so let me remove those strikes. And what we have left here is just the sine of ln of 6x. So we're going to set it up again by parts. So, but this time my u is equal to sine of ln of 6x du is equal to cosine of ln of 6x times 1 over x dx. dv is dx, v is x, and now we continue writing out the solution. All I'm doing only applies to this integral, so what comes before it remains intact. And here we write plus, and we have uv, which is x sine ln of 6x, minus integral of v du, but integral of v du here is just the integral of cosine of ln of 6x dx, which we realize is the original problem. So if we label the original problem as j or I or any other letter of your choice, then we can see that j, the original integral, is equal to x cosine ln of 6x plus x sine ln of 6x minus j. Add j to both sides. And I'm gonna Control C this thing. Divide both sides by 2. And don't forget the constant. So this is the final answer. So we have x over 2 cosine of ln of 6x plus sine of ln of 6x plus c. And this is the final answer. And we finished. If you have any questions about loop integrals, please let me know.